question, two blocks are given of mass 950 grams and 1.27 kilograms, and they are connected to a pulley that one of the blocks, so that one of the block is hanging freely and the other one is located on the horizontal plane. The friction coefficient between M2 and the horizontal surface is given, because of which there is this friction, and the system is released without any initial velocity. And M1 goes down by 53.8 centimeters. So we have to find the acceleration of the blocks and the string tension force as the first in the first part. So let's try to make the Newton's law equation of Newton's law. So for M1, that's going to be M1G minus T is equal to M1A. And for M2, that's going to be T minus F is equal to M2A. Let's call this equation 1. So we know that friction is nothing but mu k times the F sub n as in the normal reaction, or let's call it n since they are represented by n over here. That is equal to m2a, and the value of the normal reaction is nothing but m2 times g, that is equal to m2a. So this comes out as T minus mu k m2g is equal to m2a. Let's call it equation 2. And if we add equation 1 and equation 2, the minus t and plus t will be cancelled. So we'd be left with m1g minus mu k m2g is equal to m1 plus m2 times a. So g is taken out. We are left with m1 minus mu k m2, and dividing both sides by m1 plus m2, we get this as a. So all we have to do is plug in the value. So g is 9.8, m1 is 0.95 in kilograms, minus mu k is 0.31 and m2 is 1.27, right? 1.27, and this should be divided by m1 plus m2, so that's 0.95 plus 1.27 once again. So that's where the calculator comes in. 0.31 times 1.27 0.95 minus this value times 9.8 over 0.95 plus 1.27. So this value comes out as 2.46 meter per second square. So that is the acceleration. And if we have to find the tension force, so we can use the equation 1 over here. So it says that if you rearrange, then tension will come out as m1g minus m1a, and m1 is taken out, which is 0.95, and g minus a, g is 9.8 and a is 2.46. So what is the tension? The tension comes out as 9.8 minus this value times 0.95. So this value comes out as 6.98 Newton. That is the required tension. Then they're asking that in the part B, what is the change in the potential energy of each block and for the whole system? So they're only asking the change in the potential energy. So remember that mass m1 is always sorry, m2 is always on the surface. So with respect to this reference, for the change of the potential energy for m2 is 0 because it is not changing height. But for potential for m1, definitely there is a change because it goes down by 53.8 centimeters. So its final potential energy will become minus m1gh, and initial is anyway 0 because it is at the reference. This will become minus of 0.95 times 9.8 times the height, which is 0.538 meters. 0.538 meters. So this value comes out as 0.95 times 9.8 times 0.538, which is coming as negative 5 joules up to 2 decimal places. I mean, actually, it's negative 5.01 to 2 decimal places. And then we talk about part C, that what are the speed of the block and their kinetic energy. What are the final speed, as in after traveling this much, what is their speed? So speed v is equal to v naught plus at, right? Or perhaps let's use the third equation of motion. v square is equal to v naught square plus 2as. Initial speed is 0, acceleration of both is same, and the displacement is 0.538 for both of them. So this is their speed, which is same for both. So that's 2 times 2.46 times 0.538, which is coming as 2.65 meter per second. That is the value of v square. So the value of v from here comes out as 1.63 meter per second. And as far as the kinetic energy is concerned, we have to take the mass into account. So kinetic energy of m1 is half m, which is 0.95, times v square, which is 2.65, and the kinetic energy of m2 is going to be half m, which is, I think, 1.27 times v square, which is 2.65 once again. So that's going to be 0.5 times 0.95 times 2.65, which is 1.26 joules up to 2 decimal places. And for the other one, that's going to be 1.27 times zero point 0.5 times 2.65, which is 1.68 joules up to 2 decimal places once again. It also asks if the kinetic energy, if the total energy is conserved. So no, the total energy is not conserved, since there is a frictional force. So because of the friction force over here, and that is because of which, since there is an external force, so the kinetic energy is not conserved. I'm sorry, the total energy of the system is not conserved. Thank you.